All right, let's go over the questions from exam 3. So question 1, you have two pieces of information. You have the marginal cost, an expression for the marginal cost, and you also have the fixed cost. And from that, you're asked to find a total cost function. So what you're essentially being asked for is an antiderivative. So let's find the antiderivative first. So I have this marginal cost function. So first I'm going to take an indefinite integral of that. So the indefinite integral of 10 plus n squared over 10,000 with respect to n. So that right there will give me part of my total cost function. So if I take an antiderivative of a constant is going to be 10n. And then I can use the power rule on this n squared term. So that'll be 1 over 10,000 times n cubed over 3. And when I take an integral, I always have to have a constant, arbitrary constant of integration. So now we can do some simplification. So 10n plus n cubed over 30,000 plus c, and that's going to be, we'll call that c of n, or not c, we're already using c, f of n. So this is our total cost function, but we do have enough information to figure out what that value of capital C is. So the fixed cost, basically, that's how much it costs, just kind of like that's overhead. How much does it cost to produce nothing? So basically, how much does it cost, like payroll, keeping the lights on, rent, those kind of things. So I know when n equals 0, my cost is 100,000. So I know that f of 0 is going to be equal to 10 times 0 plus 0 cubed over 30,000 plus c, that's equal to 100,000. All of these terms except for c goes to 0. So that means that c is equal to 100,000. So our function for our total cost will be 10n plus n cubed over 30,000 plus 100,000. Right, moving on to question 2. All right. So we have a rate of change function. So we know the rate at which bottled water are sold per capita over this period of time. We want to find the total the total number of bottles of water sold per capita. Just like the last question, we want to find this as a function. So if we want to go from a rate of change function to like some kind of accumulation function, that involves an antiderivative. That involves an indefinite integral. So again, I wanted to take an antiderivative of the rate of change function. So 0.25 t squared minus t plus 29 with respect to t. And what will that give me? That'll give me 0.25 times t cubed over 3 minus t squared over 2 plus 29t plus c. Let's clean some of these things up a little bit. So 0.25 is the same as a fourth, 1/4 times a third. So this gives me t cubed over 12 minus t squared over 2 plus 29t plus c. I'll call that f of t. All right. So do I have enough information to figure out what c is? So let's look at the question again. So t is the time in years since the start of 2007. Find the total per capita bottled water sales as a function of the years since 2007. If per capita water sales in 2010 was 100 gallons. Okay, so I think we do have a piece of information. I think we have that f of 3, because we know something about 3 years since 2007. F of 3 is 100. Okay, so we know that f of 3 is equal to 3 cubed over 12 minus 3 squared over 2 plus 29 times 3 plus c, and that will equal 100. So this is enough information for us to solve for c. So 27 over 12 minus 9 over 12 plus 29 times 3. All right, so now I can solve for c. So 100 minus 87 minus 27 over 12 minus 0.75. So from here, I get that c equals 10, and that was the last piece we needed. So now I can write down my full function of f. So t cubed over 12 minus t squared over 2 plus 29t plus 10. All right, that's all for question 2. Moving on to question 3. All right, so the Great Recession, so attributed to the real estate subprime mortgage crisis in 2006. So again, we have a rate function. So the number of housing starts per year is given by this function here. And from here, we want to find the total number of housing starts. So there's a key difference between this question and the two that came before it. We don't want a function this time. We want a number of total housing starts. So we don't want an indefinite integral. We want a definite integral. So we have to set this up a little differently. We're still going to take an integral, and the function we're integrating is going to be an n of t, so 2400 times e to the negative 0.25t minus 200 with respect to t. But now we're going to have limits of integration. So t is the time in years since January of 2006. So we want to know the number of housing starts from January 2006. So that tells me time equals 0. So I want to know from my reference time to some point in the future. So through June of 2009. I believe that's 3.5 years. So the beginning of June, so the beginning of 2009 would be 3 years. Through June would be 3.5 years. So I'm going to take an integral of this function over the interval from 0 to 3.5. All right, so now we need an antiderivative. When we take an antiderivative of exponential functions with a base of e, this will be 2400 e to the negative 0.25t divided by negative 0.25 minus 200t. And we're going to evaluate this from 0 to 3.5. Before I do that, I'm going to clean this up a little bit. 2400 divided by 0.25. That's the same as multiplying it by 4. So 2400 times 4. So this becomes negative 9600 e to the negative 0.25t minus 200t. Now we can use the fundamental theorem of calculus to evaluate this at both ends and find the difference. So when I plug in 3.5, what do I get? I don't need the brackets yet. Negative 9600 e to the negative 0.25 times 3.5 minus 200 times 3.5. And then from that, I'm going to subtract all of this, minus 9,600 e to the 0 minus 200 to the 0, or times 0. All right, so this term falls off. That goes to 0. This term, or this e to the 0, becomes 1. So got a couple terms to approximate. The other two became pretty simple for us. So 3.5 times 0.25, and raise e to that. So negative 4,000. Let's not round to the very end. Negative 4,001.86. No, 88. Plus 9,600. Okay. 9,600 minus 700 minus 4,001.88, and I get 4898.12. But it asked me to round it to a certain level of accuracy. All right, but this is in thousands of starts, right? So 4,898.12 thousands homes, 1,000 homes. And I want to round that to the nearest 0.1 million. So let's rewrite this. 4.89812 million. So rounding that to the accuracy that we want, that's approximately equal to 4.9 million homes. All right, moving on to question 4. All right, Sony's marginal cost for manufacturing PlayStation 4s per hour is given by this function. This one I think is unique because, oh no, so we had one like this where the variable, the input variable, the independent variable was a quantity of units. And that were question 2 and 3, the input variable was time in years. Okay, so I was wrong. We have had a question like that. So what we want to find out is we want the profit. We want to figure out the total additional profit from this marginal cost function. So there's actually a couple steps we have to do here before we can just integrate that. So I want to find the total profit. So what I have here is marginal cost. So marginal cost. So if I want total profit, I need to integrate marginal profit. So how do I get from marginal cost to marginal profit? So let's first figure out, let's remind ourselves of how those things are related. So what is profit? Profit is a difference between revenue, which is the money I bring in, minus the cost, which is the money that I send out, the money that I spend on things. So, and really I can attach the word marginal to all those things. Marginal profit equals marginal revenue minus marginal cost. So what is my marginal revenue? We'll call that R of N. What's the marginal revenue? Basically, how much money do I make for a PlayStation 4? How much money comes into my company? How much money comes into Sony? On average, $400. So that's a pretty simple function. We're basically treating that as a constant function of $400. So that's my revenue function. My cost function is what's given to me, my marginal cost function. So that means my marginal profit function is the difference of those two things. 400 minus, and we got to be really sure that careful we're subtracting the entire cost function. So 340 plus 0.001n, and then all simplified 60 minus 0.001n. So that's my marginal profit function. So I kind of think the most important part of this problem is getting that function. I mean, the integral is obviously important, but getting the right function to integrate is probably the more important part of this question. So now that we have that function, so haven't you really even read the last sentence here? Determine the total additionally hour profit corresponding to an increase in production. So if you ramp up production from 50,000 units per hour to 60,000 units per hour, so assuming I sell every single one of those additional units that I make, how much more money, how much more profit am I going to make? So let's figure that out. So by the way, not how much total money am I going to make, or not, sorry, I keep saying money. I need to be more specific. I'm not asking for how much total profit am I going to make from all 60,000 PlayStations, just the additional. So I'm going to integrate from 50,000 to 60,000 of this profit function. 60 minus 0.001n dn. So basically, this right here is going to give me how much additional profit am I going to make from that specific set of 10,000 PlayStations. So the antiderivative here is going to be 60n minus 0.001n squared over 2. And we're going to evaluate that from 60,000 or 50,000 to 60,000. All right, so 60 times 60,000 minus 0.01, nope, 0.001. I put an N in here, that should be a 2. Times 60,000 over 2. Square that. And then subtract off everything at the lower limit. 60 times 50,000 minus 0.001 times 50,000 squared over 2. All right, so now that we've done that, let's do some calculating. So just some abbreviating, 3.6 million minus 1.8 million minus 3 million minus 1.25 million. Okay. So 3.6 minus 1.8 minus 3 plus 1.25. Let me try that again because that came out very small. I want to make sure. 3.6 minus 1.8 minus 3 plus 1.25. Well, that's what I'm getting. So that equals 0.05 million, which we can re-express as what? If I slide it over 3 places, I get what? 50K, so $50,000. So that is my total profit, or no, keep saying total profit. That's the additional profit from making 10,000 extra PlayStation 4s. So is it worth it? No, not that I asked you to talk about this question, but basically for those 10,000 PlayStations, you averaged $5 a profit for each one. But if I look at my marginal profit function, your profits are diminishing. The more PlayStations you make, the less profit you make from each one. All right, moving on to question 5. All right, the following models show the rate at which new members join Facebook and MySpace over a 3-year span, where T is the year since the start of 2005. Which of the two internet sites experienced a larger influx of new members from the start of 2007 through June of 2008? How many more members joined that site? Okay, so I want to know which site picked up more new members. This is an application of basically the area between curves. And you can answer this question by integrating both f of t and m of t separately and seeing which one's larger. You don't have to do that. So I'm going to do that in what I think is a more efficient way. I am going to integrate f of t minus m of t with respect to t. And I also want a definite integral. So I am integrating from the start of 2007 through the middle of 2008. And t is the start of 2005. So I think I'm integrating from t equals 2 to what? T equals 3.5. Okay. Also, so I'm asked two things. Which of the two sites gained more members? So how am I going to answer that question? Well, if this integral comes out to be a positive number, that'll tell me that Facebook gained more members. Negative numbers going to tell me that MySpace picked up more members. And then whatever the number is going to tell me what the difference was. Okay, so now, before I actually do the integral, I'm going to actually do some simplifying here. And these are both quadratics. I can just kind of make this subtraction. I'm going to go ahead and do it on the fly. So the integral from 2 to 3.5 of, if I subtract the squared terms, 12 minus 10.5 is going to be 1.5 t squared. Negative 20 minus 25, so negative 20t minus 25t is minus 45t. And 10 minus 18.5 is minus 8.5. So this is the function I am going to integrate. So now we can use the power rule. So 1.5 times t cubed over 3 minus 45 times t squared over 2 minus 8.5t. And I'm going to evaluate that from 2 to 3.5. But before that, let's do some simplifying. 1.5 over 3, that'll be 1/2 t cubed. 45 over 2, that doesn't really reduce. So 45 over 2 times t squared minus 17 over 2 times t. From 2 to 3.5. All right, so now we can plug in and evaluate. 1/2 times 3.5 cubed minus 45 over 2 times 3.5 squared minus 17 over 2 times 3.5 minus 1.5 times 2 cubed minus 45 halves times 2 squared minus 17 halves times 2. All right, so let's punch it out. Eight over 2 is 4 minus 4. 2 is 2. All right, now I can add them all together. 21.4375 minus 275.625 minus 29.75 minus 4 plus 90 plus 17. And I get, all right, the final result is this, negative 180.9375. So what does that number mean? Well, that means two things. That means that MySpace picked up more members because I got a negative value and I was subtracting M. So during that time period, MySpace gained more members and they gained 180 million more members. All right, moving on to question 6. All right, revenue from the sale of new homes in the US decreased dramatically from 2005 to 2010, shown by this rate function. If this trend were to continue into the indefinite future, estimate the total revenue from 2005 on. Okay, so this is, so from 2005 indefinitely. We're looking basically at an indefinite, or sorry, an improper integral. So basically, we're looking at this 5-year model, and we're going to extrapolate it far into the future. So I'm going to integrate it from 2005 is time equals 0 to time equals what? From now on, time equals infinity. And I'm going to assume that the rate of change of the revenue from the sale of new homes fits this model forever. If it does that, let's see what happens. So when I'm dealing with an improper integral and one of the limits is infinity, I need to set up a limit. So the limit as b goes to infinity of the integral from 0 to b of 412 times e to the negative 0.323 t with respect to t. All right, so let's go ahead and take the antiderivative of this. So the limit as b goes to infinity of 412 e to the negative 0.323t over negative 0.323. And we're going to evaluate that from 0 to b. So what is 412 over 0.323? So the limit as b goes to infinity of negative 1275.54 times e to the negative 0.323t from 0 to b. I think from here I don't need a calculator anymore because I think I can think about what happens as e goes to 0 or as e goes to infinity. So let's plug in these limits and see what happens. So as the limit as b goes to infinity of negative 1275.54 as e goes to negative 3.23b minus negative, so plus 1275.54 times e to the 0. Okay. So e to the 0, that is 1. So basically this right-hand term is going to be 1275.54. But what about this left-hand term? What is going to happen to this e term as b gets really, really large? Maybe it'd be easier to think about if we rewrote this as the limit as b goes to infinity of negative 1275.54 over e to the positive 0.323b. And then this I'm just going to write as 1275.54. What's going to happen to this denominator as b gets really, really large? This denominator is going to get very, very big. The numerator is not going to change. So this term on the left is going to just trend closer and closer and closer to 0. So that means this limit, basically this term on the left is going to trend to 0. So this improper integral converges to 1275.54, which means if the revenue gained from new home sales continues to follow this model forever, then the amount of money that will be gained from new home sales will be $1.275 trillion from now until the end of time. All right, moving on to question 7. All right, suppose your annual income is given by this function I, and your annual expenses can be given by E. Find the area between the graphs of I and E over the first 5 years. All right, so we'll do that first. So I want to find the area and over the first 5 years of my job. So the area between those curves, the way I find the area between curves is with an integral. It looks like I'm assuming that, I don't know, the way this is written is implying that I minus t, but I don't think it really matters. I mean, if we get a negative number, we know how to interpret that. So this is the integral I'm basically being asked to compute. But before I do that, I think there's some simplifying that can be done. These are both linear functions, so I can make some subtractions kind of on the fly again. 37,000 minus 36,000 is 1,000. And 3,000 minus 3,200 is 200t. So I believe what I am integrating is 1,000 minus 200t dt. So if I integrate that, I need an antiderivative, so that'll be 1,000t minus 200t squared over 2, so 100t squared. And if I integrate that from 0 to 5, I get 1,000 times 5 minus 100 times 5 squared minus 1,000 times 0 minus 100 times 0 squared. And now, so all of this is going to go to 0. What happens over here? This becomes 5,000 minus 100 times 25. So 2,500. So I get a positive number of 2,500. So part of this was just to find the area between the graphs, and I got the number 2,500. So now the second part is, what does that number represent? So my annual income was given in dollars per year. My annual expenses was given in dollars per year. I integrated those both. So basically the difference in my income and my expenses, basically that's still going to give me a rate. So if I integrate over that rate over a period of years, that's going to give me a number of accumulated dollars. So I accumulated positive $2,500. So basically what this integral told me is that over 5 years, I saved $2,500. All right, and that's all for exam number 3.